Make sure you correct, and I know who didn't do it, so don't be trying things, okay? So 20, I'll find a 24, this is 16 and 24, that's 40, right? I don't have the key in front of me, so you're gonna have to catch it if I make a mistake. What are the odds? The odds in favor of a fish being a walleye. So odds, because it's odds in favor, we want walleye first and the ones that are not walleye second. So we go 3, and this should be 37. So 1 mark. What are the odds against a fish being caught being a pike? Because it's against, we go not pike first and pike second. But I find the pikes first, so this must be 27, right? Because together they add up to 40. So you go 40 minus 13 to come up with that. Okay, so 1 mark for that. What's the experimental probability of Mr. Erickson catching a bass? We have 40 total, and 24 of them are bass, right? Why does it say experimental? Does it make sense that it's experimental? It's based on what happened, right? So don't let that throw you off. It should be.
Excuse the interruption. Anthony and Victor, before Bell, please make your way back to the gym. Anthony and Victor, please make your way back to the gym.
Okay. We're good? There's a contract with the city. The proposal costs $1,000 to make. The contract will pay $7,500 if for the business owners, and there's a 40% chance of winning or getting the contract. So expected value is 0.4 times 7,500 minus the $1,000 that it takes you to play the game, so to speak. So we'll figure this out. This is 3,000 minus 1,000. So this should be a total of $2,000 positive is your mark there. So you get 1 mark, 1 mark for this portion right here, and then 1 mark for subtracting 1,000 from whatever you get there. Okay. Would you recommend the business to make the proposal? Yes. Expected value is positive. I think that's a little bit too cheap, right? You want to like write at least expected value is positive. Try not to shorten it too much, but I'm just doing it for the purposes of this example. 1, 2, 3, and another 3. This page is worth 6. So we're going to have a big running total here so that we have a grand total at the end. Backside. A spinner is pictured, right? You can pay 10 game bucks to spin a spinner. So we're not actually talking about actual money, but game money, I guess. But we can still see it as dollars if you want. That's the price to play. If you get a yellow, you get 50. If it lands on blue, you get 20. If it lands anywhere else, you lose money, right? You don't get your money back. That's the expected value. So this is prize 1. This is prize 2. Okay. Can we for now pause our conversations? I want to get through this, okay? Expected value. Yellow. We only have 1 yellow, right? So 1 out of 8. Okay, 1 out of 8. And then we win 50. The second prize, if it's on blue, we've got 3 blues there. And then this is times 20. We don't have any other ways to win anymore, so we just go minus 10. Okay. So I'm just going to do this 1 divided by 8 times 50. This is 625 plus, you go 3 divided by 8 times 20. You get 750 minus 10. And now you add it all up. This should be 375 positive, right? So you get, I'm going to give this marks because there are no marks attached, right? I would say this gets 1 mark, this part gets another mark, and then subtracting the 10 at the end gets you the 3rd mark. This is pretty much in line with the province would do. Okay? So worth 3 marks. So let's do the subtotal for just this one AC. So 3 and 6, that gets you a mark out of 9 here. So put a mark down out of 9. This is 1 out of 4. Okay, this is the first AC that we did. Okay, next is this one. So that one is out of 9, okay? Probability and odds. So the odds of a student passing Mr. D's math class are 14 to 1. State the probability of a student passing. I hope you know that you add these up to 15, right? So this should be out of 15, and 14 would be the number that goes on top. So I'll give you 1 mark for the 15, 1 mark for the 14 today, just like that. If Mr. teaches 95 grade 12 students each year, how many will pass this math class? 95, right? You multiply it by the probability. You're making a prediction. 1 second. That is 88.6 something. So you can say 88 or 89 students. Okay. The probability of Sisler's volleyball team winning an upcoming tournament is 4 over 15. State the odds of Sisler winning the tournament. This would be 4 to 11. Because they add up to 15, right? Total is 15. That's always something to check. So I'll get you 1 mark for the 4, another mark for the 11. So if you've got 4 to 15, technically for the province you would get 0, but you're still learning. So we'll give you 1 and 1. State the odds against winning. So you just flip. All I would want you to, what I would want to see is this is flipped because you're going against. So from odds to odds, you're just flipping. You're not adding or subtracting anything. There are 4 blue, 6 green, 5 red marbles in a bag, so 15 total. What are the odds against drawing a blue? Against blue means that it'll go in this order. So I have 4 blues here, which means I will have 11 over there. These are all the non-blue marbles. Or if you want to think of it as the red and the green are on that side. What are the odds of drawing a green marble? You want green and not green like that. There's 6 green and therefore 9 that are not green. Okay, so always check, do they add up to my total of 15? The probability of drawing a red marble, now you want, because it's probability, you want it like this. A red, we've got 5, right? 5 over 15. So I'll get you 1 mark for each. Same over here, 1 mark for each. If it's a 2-mark question, I'll give you 1 mark for each one of them. So try to see if you got some partial marks there. The odds against drawing a red one, we want it in this order, against. So we've got 5 reds and therefore 9 that are non-reds. There you have it. 1 mark for each. Oh, 10, right? My bad, my bad. Did you do this, make the same mistake? Okay. Yeah, sorry, I'm getting older. The Jets play the Senators. The odds of the Jets winning are 5 to 4. So you know this is W and this is not W, like losing, right? Because of the way it's stated. What are the odds against the Jets winning? You just go 4 to 5. That's all. You flip that one. What's the probability of the Jets winning? We add that up. That gets us 9, right? And we want the 5 on top. So it's 5 over 9. You get 1 mark for each of them. Oops, can you see? You cannot see. There. State the probability against the Jets winning. We would just go 4 over 9. Because, right, we want the 4, which means against winning, over a total of 9. So you get 1 for each of them. So 2, 4, and 1 is 5. 7, 9, 11, 13, 14, 16, 18, and 1 is 19. So this page is worth 19 marks. So try to add it up and see if you, sometimes it's easier to just find the mistakes and subtract every mistake from 19, and then you get it that way. Okay, next you're spinning the wheel. She spins 25 times. These are the results. What are you thinking of? Results, experimental versus theoretical. That's what this is trying to test you on, okay? So state the probability of the spinner landing on purple. Theoretical, we're gonna go by this. Experimental, it's gonna crisscross. We're gonna go by this, okay? So let's do the math here. 8 and 7 is 15. Another 10, that's 25 total. We already knew that, but I'm just double checking. Theoretically speaking, purple, there are 2 out of 5. In theory, this is what should happen, and this is what we would expect to happen in the long run. Experimental, we got to go back to this. We spun it 25 times, and it landed on purple in four of those occasions. You get 1 mark for each. Oh, it says fraction and decimal, right? 4 divided by 25, 0.16. I knew that, but hey. Next, the probability of the spinner landing on red. Theoretical should be out of 5. There's only 1 red section out of 5, right? So that's 0.2. Experimental, we're back to the 25 experiments, and it landed on red on 7 occasions. That'd be 0.28. Okay. I honestly today don't care if all you did is a fraction. That's the one I really I'm emphasizing the most here. I'm not too worried about the decimals. I mean, of course, if you want full marks, if they ask for it, you should be able to do it. State the odds of the spinner landing on purple. Watch this. Because it's purple, I'm going to use these answers to help me out here. So this should be 2 to 3, because remember, I want a total of 5. And this will be 4 to 21, because I want a total of 25. Okay, so there you have it. Flora spins a spinner 1,850 times. How many times would you expect it to land on yellow? We got to use the theoretical probability. So yellow is 1 in 5, right? So 1 over 5 times 1850. So 0.2 times 1850, that's 370 exactly, okay? So you get a mark for the 1 over 5, and you get a mark for multiplying it by the larger sample. We always want to use the theoretical to make a long-term prediction. If there is more, like if you have both probabilities, you want the theoretical, okay? Okay, let's do the subtotal for the back here. I'm just going to give you what the breakdown is for this part. I'm just going to say you get 2 marks. You get 1 and 1, 2 marks here, 2 marks there. So 2, 4, 6, 8. Right? So every box is worth 2. So you've got a total of 8. 8 and 19 is 27. Hey, we got it right. It's at the top already. So we don't even have to cross anything out. Put this one away. This one is 2 out of 4. Is this just a one pager? Yeah, okay. This is what I have as my third one. So 3 out of 4. If you staple it, I don't think you need to worry about it if it's in this order anyways. At the Red River X, you play a game where the chances of winning is 55%. If you win, you will get 15 tickets. If you don't receive any tickets. You must give the operator 10 tickets per play. What's the expected value? So it's interesting, no dollar amounts, but there's only one way to win. And if you win, you get 15 tickets. So this is kind of like your dollars, right? But except for we won't put dollars because you're winning tickets. Minus you pay 10 to play. So let's figure out this. 0.55 times 15. It's 8.25 minus 10. That'll be negative. Oh, I want to put a dollar sign in there, but I shouldn't. Negative 1.75 tickets. In this case, that's the unit. Like you'd be losing 1.75 tickets on average every time you play. Is this good for the Red River X? For them, for the host? Yeah, because you are losing. Every time you play, well, not every time, right? But in the long run, this is what it would end up being. So for them, it's good. For you, it's bad. Okay, so I will just make a note here. Bad for you. Good for host. Okay, because EV is negative. Okay. If you play the game 20 times, how many tickets are you expected to lose? So 20 times 1.75. That's 35 tickets. Okay. At the end of the conference, there's a fundraiser to set up with a wheel. Participants, they pay $10 to spin. If it lands on a star, you receive a gift card for $50. If it lands on anything else, you don't get a cash prize. There's 10 stars, 20 X's, and 40 O's. So you gotta be careful. 10 and 20 is 30, and 40 is 70. So 70 total. Wow, that's a big spinner, right? 70 sections. What are the odds of the wheel landing on a star? There are 10 stars, and therefore 60 are non-stars. Okay. What's the probability of a wheel landing on a star? Probability. That's when you want to introduce the 70. And there are 10 out of 70. 1 out of 7 if you want to reduce it. Expected value. We would go 10 over 70 times $50. This is actually cash, right? It's a gift card, but we treat it as cash. Minus $10. So again, you get a mark for this part, and you'll get a mark for subtracting it by 10. So for this part, you get 7.14 minus 10. So you get negative $2.86. So you get a mark for that one, for subtracting 10. So if you make a mistake here, you lose a mark immediately. But if I see you subtracting by 10, you get that second mark. So 2, 4, 6, 7. So this one is just 7, right? This whole thing is 7. Last but not least, and then you'll write another AC for me. Yeah, I know. I know what you're thinking. You couldn't wait. Yes, I know. Explain how you know when events are dependent. Your own words. It's fine, guys. It's fine, guys. If the first event affects the second. Okay, that's probably short. Example, yeah, removing removing objects without replacement. That's replacement. That would be like a specific example. Like if sometimes they've asked students to come up with an example, just bag of marbles, guys, or a deck of cards. There's like 6 reds, 4 blues, someone grabs one, doesn't replace it. What's the probability of getting a red one on the second draw? Boom, you've got an example, right? That's one of the best ones you can use. What about independent? I would say a spinner and a die, or coin and a die, or something, like something that doesn't affect. You can't remove anything, it just stays, right? Gurpreet draws a card, draws a queen of diamonds, and does not replace it. Dun, 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 right? You know what's happening here, hopefully. Does not replace the card. So now we're drawing a second. And every time you reset to the beginning, okay? What's the probability of the second card being a 5? First of all, we know we're down to 51. The number of 5s has not been affected. So it's 4 out of 51. We reset it. We go back to the beginning. We're down to 51 again. The second card being a queen, this should be 3 out of 51 because we used to have 4 queens. 1 has been removed. So 1 and 1. Okay, you get 1 mark for each. The second card being a face card, you used to have 52, now you're down to 51 because the queen of diamonds has been removed. You used to have 12 face cards, right? It happens to be a face card. The queen of diamonds is a face card, so you're down to 11. You get 1 mark for each. What's the probability of the second card not being a queen? 51. Not being a queen. How many non-queens do we have normally? If 4 are queens, then 48 are not queens, right? Have any of these been removed by the first one? No, right? The queen has been removed, the non-queen stayed the same. So that should be 48 over 51. Let's make sure we have this 4 queens, and this is other. Go ahead. 4 queens and 48 others. So the total has changed, but the not being a queen stayed. It's still 48. Okay. Anthony rolled a 12-sided die 30 times. So this is the object. Think of it as a spinner with 12 sections or 12-sided die. 30 times it has happened. It landed on a 7 in 11 occasions. What's the experimental probability of rolling a 7? It's 11 out of 30. If there was ever a somewhat unfair question, this one was it, right? The theoretical probability of rolling a 7, it's 1 out of 12. Because you've only got 12-sided die, okay? 30 rolls, basically, okay? So that's why this is out of 30, this is out of 12. If Anthony rolled the die 1,500 times, how many times would you expect it to land on a 7? We take the theoretical probability, we multiply it by 1,500, and it's exactly 125 times. So you get 1. This should not be a 2-mark question, but we'll leave it. 1 for this part, and 1 for multiplying. Okay. It has to be a whole number on these ones. Next, Emma has a jar containing 4 and 5 is 9 and 7 is 16 total. She picks a random candy, gets a blue one, replaces it, picks up another one. What's the probability of the second candy being red? We still have all 16 and we still have all 5. Okay? State the probability of the second candy being blue. We still have 16, we still have all 4. Nothing has changed in this one. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 for this page. It's just a one pager? Thank goodness. Okay, so this is 4 out of 4. So let's do the grand total, okay? You ready for the grand total? So we're gonna go 14 plus 7 plus 27 plus 9. So you should have a grand total of 57. Oh, should have added another 10, right? What a day that would have been. Out of 57. That's it.